This topic is the part of the receivers, AM and FM receivers. So normally communication SSB and ISB receivers are the basics of AM receivers or a part of AM receivers. So we will see one by one. Now what is communication receiver? The main function is the reception of signal used for communication. Obviously, the receiver function is to receive the signal for the communication purpose. Communication receivers applications are detection of signals from high frequency impedance bridges. It should be able to detect the signal from the high frequency impedance bridges. Means what, like frequencies are going to vary, like in AM the frequency is lesser while in FM frequency is more, so it should be able to detect the signal from the high frequency bridges. It should be able to measurement of the signal strength. It should be able to measure the signal strength. It should be able to measure the frequency. Means what, it should be able to identify the frequency, detection and display of individual components of high frequency wave like FM wave. Now antenna receives. Now if you see the block diagram, so normally the first thing will be the antenna. So in the next slide we will see the diagram. So normally antenna receives the signal based on the impedance matching and applies to the RF amplifier stage. So what is the function of antenna? To receive the signal. So based on the impedance matching, the received signal will be maximum, or the power of the received signal will be maximum. So the impedance matching with the environment impedance matching, which is normally we take 15 ohms, it should be matched properly, and the received signal will be given to the RF amplifier stage. The RF amplifier amplifies the signal, obviously, which is in the range of 2 to 16 megahertz, and provides high sensitivity and low noise. Then this signal is given to the first stage mixer. The first stage mixer receives signals from the RF stage and from local oscillator. So the mixer is going to receive two signals: the signal coming from the RF stage and signal coming from the local oscillator, whose frequency is in the range of 3.7 to 17.7 megahertz. So here if you see this block diagram, so here we can see here this antenna coupling unit, so for which we have talked about already. Then there is a first stage RF amplifier, which is having frequency of 2 to 16 megahertz. This output is given to the first stage mixer, which is having frequency 2 to 16 megahertz. One signal coming from here, the other signal is coming from the local oscillator. Now this signal, the output of first mixer is going to the again second stage IF amplifier. Then again the output is given to the second stage mixer, and then again second stage IF amplifier again given, or we can say this is the first RF amplifier and this is second stage RF amplifier. Now why there is a need to two stages RF amplifier, we will see, we'll discuss it now. But if you observe properly, the first stage RF amplifier IF amplifier frequency is 1.7 megahertz, while second stage IF amplifier frequency is 200 kilohertz, so it is lesser. Then this is going to be the on-off switch, which is a beat frequency oscillator, BFO. This oscillator is having a main, it is having some operation. Then this signal is coming to the ADC amplifier, which is able to control the gain. The ADC detector is there to control the output of the gain. Then detector is demodulator, we can say. This output is going to the squelch circuit. Squelch circuit is the important circuit, which is actually whose main function is to detach the detector from the reception if there is no carrier is received. Then audio amplifier and the power amplifier. So audio amplifier should to amplify the audio, and the power amplifier to increase the power so that it can be given to the speaker, which can generate or which can detect or which can ignite the speaker. So we'll see the function of each blocks properly. So out of that, these three blocks function we've already seen. Now the mixer produces the output same as a super heterodyne receiver. So normally in super heterodyne receiver, how the mixer produces output, it produces two output, addition and subtraction, or the subtraction frequency is taken as IF frequency. So first stage IF amplifier selects the difference frequency, which is FS minus FC, or FS local oscillator minus frequency. So which is 1.7 megahertz, and amplifies it and gives to the second stage mixer. Again second stage mixer with it mixes with another locally generated crystal oscillator signal mixed at 1.5 megahertz. So this difference of 1.5 and 1.7 and 1.5 will give it 200 megahertz. So that's why the output of the second mixer is 200 kilohertz, which is going to be the second stage IF amplifier, which selects the second IF frequency, which is 200 kilohertz. First stage IF amplifier is usually in megahertz, while second stage IF amplifier is in kilohertz. below, up to it should be below the 1 megahertz. Now why there's need for double conversion? First it is in megahertz of 1.7 megahertz, while in second it is 200 kilohertz. The advantage is that the first stage IF amplifier pushes the image frequency further away from the signal frequency. So it pushes the image frequency. So there is will there so because of the frequency is far away from the original frequency, the image frequency, so there will be no image rejection will take place. And low IF has all the advantage of low impedance, low fixed operating frequency, and second stage is giving a low frequency, so it takes all the advantages of the low fixed frequency, like sharp selectivity, because if the frequency is low, selectivity is good, a good adjacent channel rejection, and also adjacent channel rejection also is possible at the low frequency. So these are the main reasons. And also double conversion is used in crowded high frequency and other bands. So double conversion normally is used when there is a crowded, means what, if high frequency bands is very crowded, means what, we are the signals are very close to each other in a spectrum. So in that cases double conversion is more beneficial, because during transmission we can use high frequency, but in the second stage or during double conversion we can convert that into low frequency, so that advantage low frequency can be used. So this is the reason we go for double conversion. Then bit frequency oscillator BFO is used to receive Morse code. It can be simple LC oscillator operating at a frequency range of 1 kilohertz to 400 kilohertz below the last IF stage. So it should be below the last IF stage. So what IF stage is, frequency should be lesser than. Now when IF is present, intermittent frequency is present, a whistle is heard in loudspeaker, which is combination of the receiver, detector, input signal and beat frequency oscillator. So the whistle signal is coming because of the combination of the receiver, detector, input signal and beat frequency oscillator frequency. Now during non-telegraph reception, BFO is switched off to avoid interference. So non-telegraph reception, normally the BFO is switched off because otherwise it will produce interference. Then squelch circuit, also called as a muting circuit. Why it is used? So it enables the receiver output to remain cut off. It detaches it, or we can say it detaches the receiver when the carrier is absent. So when the carrier signal is absent, it detaches the receiver. So it cuts off the receiver. Hence, squelch is also called as a muting or cuting. Why there's a need of squelch circuits? When a carrier is absent, a sensitive receiver will produce a large amount of loud noise. So when the carrier is absent, the sensitive receiver will produce a large amount of loud noise as ADC disappears in absence of carrier. So when there is no carrier, ADC will not work. So ADC voltage will not be there, so means what, gain will not be controlled. In that case, the amplifiers will amplify the noise actually. So the receiver gets its maximum sensitivity and it amplifies the noise present in the input. Hence, the receiver system needs to cut off from this annoying noise, which is possible by muting the receiver. So to cut out that, so to stop that amplification, so that to cut out that receiver from this high noise, squelch circuit is used, or we can say muting of the receiver is done. So this is squelch circuit. So we can see here we have first AF amplifier, so this is audio frequency amplifier which will amplify the output. Again here it is second stage, which is DC amplifier, which amplifies the DC signal. Now these two operate in a we can say complement of each other. So one is operating, other is not operating, or this one is operating, T1 will not operate, like that. And low adjustment with this R3 will adjust the level. How? We'll see the function. Now when AGC voltage is low or zero, when AGC is not present, what will happen? The current is drawn by the DC amplifier. So what will happen when AGC is low, when AGC is not there, the current will be drawn by the DC amplifier. Means current will, because this is not given, so current will be drawn by the DC amplifier. So current will flow through DC amplifier, which is T2. And voltage drop across R1 cut off the audio amplifiers T1, and voltage drop across R1. So here the very high voltage drop is there, so due to which the T1 is cut off. T1 will go in cut off mode. So therefore no signal is passed through the T1. Means AF is not coming out because output of T1 is AF signal. Now when AGC voltage is sufficiently negative, when it is negative AGC voltage, T2 gets cut off. So T2 will be cut off because AGC voltage is negative, so this will be not operating, which due to which T1 will operate because there is no voltage drop here. So T2 gets cut off, hence current drawn by the DC amplifier is 0. T1 gets self-biased through bypass emitter resistor R2. So this R2, which is a self-bias resistor or emitter bias resistor, so it will become on because here we are connecting the voltage, so it will becomes on R2 base potential resistor, and we get the AF output. So the audio amplifier works normally. So when the AGC is negative, so it works normally. When AGC is 0, this will not be working. This will work, so due to which no output is coming. Now, what is the role of RT resistor? Now, it is a dropping resistor which ensures that the DC voltage supplied to the collector and base potentiometer of T1, that is DC voltage supplied to the collector and the base potential of T1, is higher than that of the DC voltage supplied to its emitter. So the voltage of the base potentiometer is higher than the DC voltage supplied to its emitter. The cut-in bias of T2 can be varied by manually adjusting the R3 value. So cut-in voltage of T2 can be adjusted by changing the R3 value. It always perform muting quitting from the selected range of AGC values. So it is important in case of weak station. So if the station is weak, in that cases it is very important. So here we complete the communication receiver. Now we will see the remaining part of the receiver. We know that is amplification, audio amplifier in the detector and audio amplifier in the power amplifier, which is normally function to amplify the signal voltage so that it can drive the loudspeaker. Now we go for the second part, which is SSB and ISB receiver. So now single sideband and independent sideband receivers are normally used for professional or commercial communication only. Such receivers are almost invariably required to detect signals in difficult conditions and crowded frequency bands, means high frequency bands. Consequently, they are always multiple convergence receiver. So there is a multiple conversion takes place. So special requirement of SSB and ISB receivers are, what are the requirements? So we will see that the first is high reliability and simple maintenance. It should be high reliable since such receivers may be operated continuously. So there will be a chances that this receiver may be operated continuously. Therefore, should be high reliable and the simple maintenance should be there. Excellent separation of adjacent signals, so it should be able to suppress the adjacent signals properly or efficiently. Ability to demodulate SSB, it should be able to demodulate SSB. Obviously, this is very important concern. Good blocking performance, it should be able to block the frequency which is not required, and also high signal to noise ratio. It should be able to give the high signal to noise ratio, means it should not be able to generate the noise so that the signal to noise ratio reduces. And last is ability to separate the independent channels in the case of ISB receiver, and also should be able to separate the independent channels in case of ISB receiver. So we will see SSB receiver. So if you see, this is the SSB receiver of pilot carrier SSB receiver. If you see here, the input is RF amplifier, which is having a frequency of 4 to 30 megahertz. Now this will amplify the signal which is received by the antenna. Then this signal is given to the high frequency mixer. So again, mixing will be there, which is to which two signals will come. The signals coming from the RF amplifier, and the signal coming from the VFO, which is VFO is variable frequency oscillator, which is generating a frequency of 6 to 32 megahertz. So HF mixer. Now the gain also going to control by this AGC line. Now the output of this is going to the HF IF amplifier. So this will intermittent frequency amplifier. It will amplify that signal. Then low frequency mixer. Again there will be mixing because just now we have discussed that when there is a high frequency or crowded stations are there, double spotting is double mixing is used. So one mixer here, other mixer here. So it is having frequency of 2 megahertz. So lesser frequency. Then it is going to the sideband filter. So this filter will separate the sidebands 200 to 203 kilohertz. Then the output is going to the low frequency IF amplifier. So the sideband filter again going to be given to the IF amplifier. The output is going to the product demodulator. So here the function of demodulator is there. The first AF amplifier is there, which is going to give the amplifier signal and give the AF output. Now here during this operation, the carrier filter and amplification should be there, which is the frequency of 2 kilohertz. This output is going to the AGC, which detects the AGC, and this output is going to the squelch circuit. So the function of squelch circuit is same as the communication receiver only, which is the function to quit or to cut off this receiver when there is no carrier. So based on the AGC, if the AGC is voltage is 0, so there will be, it will quit the circuit, there will be no output coming, and because there is no carrier. When AGC is negative, this will work normally and there is output will come. So this is a function of which receiver, which already we have seen. Then multiplier is just to increase the sensitivity of the receiver, and then the output is given to the RF LF crystal oscillator buffer 200 kilohertz, a phase comparator. So this will compare the phase which is coming from the this LF mixer and the carrier. So the phase will be compared, and then it is going to the variable reactance modulator, which will control the voltage control variable frequency oscillator. So in which the frequency can be changed. So similar to the communication receiver, it uses double conversion and AFC audio frequency control. So we can control the frequency. So AFC provides frequency stability and also use of one local cluster oscillator with multiplication by 9, which increases the stability. The output of second mixer contains the wanted signal. So the second mixer normally contains the wanted signal, the weak carrier. So both signals it contains. So we have to separate the wanted carrier from the wanted sideband from the carrier. So that's why LF sidebands are required. These two signals are separated by filters, which is sideband filters. The sideband is given to product modulator, and the carrier is given to the ADC and AFC. So the carrier is going to the ADC, which is automatic gain control, and the AFC, which is automatic audio frequency control. The output of the carrier amplifier and buffer is given to the phase comparator. So output of carrier and amplifier and the buffer is given to the phase comparator, compares the phase. And the output of the phase comparator depends on phase difference between the inputs, and which can be 0, positive, negative. So the phase comparator is important. So based on the phase, it decides what ADC should be given. This is plus or minus like that. So it is a difference between the input and the what buffer is giving, or input and the frequency and the carrier frequency. The output of phase comparator actuates the varactor diode connected across the tank circuit of the variable frequency oscillator. So it consists of varactor diode through which if we change the voltages, the frequency will the capacitor will change, and it will generate the frequencies of different values. So based on that, variable frequency oscillator can be generated. So which general frequency is required. It also consists of ADC and squelch circuit as communication receiver. So the function of ADC and squelch circuit is same as the communication receiver, which is normally ADC to control the gain, and squelch receiver is to just to cut off the receiver when there is no carrier. Next we'll see ISB receiver, which is independent sideband receivers. So this is a block diagram of ISB receiver with a frequency synthesizer. Normally frequency synthesizer is just to control the frequency and give the proper sensitivity. So here we can see ISB receiver, the frequency of 100 kHz to 30 MHz receive, which is a protection circuit and RF amplifier. Protection circuit means what? There should be no feedback coming to the gain antenna, so that it should be protected. And then it is given to 30 MHz low pass filter, so that the low pass filter will pass the 30 MHz frequency only. Other frequency will be blocked by this filter. Then it is going to the first mixer, the mixer which will mix the signal coming from the low pass filter and the frequency synthesizer, which is giving the smooth controlled fixed frequency of 40.455 to 70.45 megahertz frequency, in the range of that, and this will generate the IF. So 40.455 megahertz bandpass filter and IF amplifier. So this is the filter which is customly this frequency, and IF amplifier which amplifies signals also. This is going to the second mixer again. Connected to this frequency only, which is giving the 40 megahertz, and this means so then again there will be IF signal generated. This has a signals of 450 because we have 40 megahertz and 40.455 megahertz. If you subtract this, we'll get 455 kilohertz signal, which is the USB bandpass filter and IF amplifier. So the 455 kilohertz signal you will get here. Then the output is going to the product detectors, which will detect the signal, and USB output is given. So and this output is again given to the 455 kilohertz LSB bandpass filter, and the LSB is given. So here USB is selected and here LSB is selected. So both bandpass filter actually are used to select. So this bandpass filter selects the LSB, and this bandpass filter selects the USB, and the output is given as a LSB output, and here it is USB output. Now here ADC detector is there, so this will control the gain of the circuits. So the circuit is similar. So the ISB receiver is able to receive all form of AM signals. RF amplifier, because its frequency is 30 megahertz. RF amplifier, it is mixed frequency RF amplifier. It may cover wideband of 100 kilohertz to 30 megahertz, for which set of filters can be used to at end of the frequency. So at end frequency we can use filters so that frequency would not be greater than that defined values. It has very high IF and about 40.455 megahertz, which can be passed by a VHF crystal bandpass filter. very high frequency band pass filter. Now the band pass filter, which provides a higher image rejection frequency rejections. This ISB receiver is actually double conversion super heterodyne receiver up to lower stages. So here also we have seen that two mixes are used, so it is also double conversion super heterodyne receiver. Mechanical filters are used to separate two independent sidebands. So we have seen that up USB bandpass filter and LSB bandpass filter. So these are called mechanical filters which are used to separate the bandpass independent sidebands, and then product demodulator or product modulator detects the separately. As carrier is not transmitted, here we are not transmitting the carrier in ISB. ADC is obtained from rectifying part of the combined audio signal. So here ADC is actually obtained by the rectification part of the combined audio signal. So combined audio signal, when it is rectified, based on that rectification, ADC is controlled or ADC is generated. AFC's audio frequency control is used for maintaining frequency stability. Frequency synthesizer generates frequency of highest stability. So frequency synthesizer is used to generate the frequency which is very stable, so that there is no variation. The presence of the frequency synthesizer, the frequency stability of such receiver can be very high. So because of frequency synthesizer, the stability of the frequency is very high. So here we finished the ISB. So in today's lecture we have seen the communication receiver, different parts of that, then SSB receiver, and then ISB receiver. So basically in all the three receivers we have double conversion, so that in high band or congested frequency band, double conversion is very helpful, because one mixer will generate the high frequency while the other mixer will generate the lower IF frequency. So that because the lower IF frequency, the advantage of lower frequency is that it gives good selectivity and stability. So that advantage is gives, and we have seen the differences in the block diagram also. So here I conclude the lecture. Thank you for listening.